back finally. I was in the hospital for a week, and I actually was kind of happy to be there because I was doing pretty poorly. I had COVID back in August, and it really never went away. I do have the compromised immune system since I had leukemia last school year, so my immune system is not strong. It's not very experienced, I should say, because I got a brand new immune system in 2018. Had to get my baby shots over again and everything. So all that experience that my immune system had was wiped out in 2018. So I'm still building immunities to all the common stuff that you guys went through as kids. So when COVID came along in August, my wife and I both caught it for the first time. And she was over it in about a week or two. And I continued coughing, and I still have a cough, but they said that could be months. And I was running a fever during October, about 101-degree fever. Every night when I got home from school, I'd run a fever for October. That was my October. Going to bed early. Went to bed early on Halloween. My wife gave out candy. I was asleep. But anyway, I had an appointment 2 weeks ago with my oncologist, and when he heard everything that was going on, he said, "You're going in the hospital." And so they started me on some COVID IV drugs for 5 days of these drugs, 3 hours a day through IV, a lot of antibiotics, a lot of fluids, chest x-rays, took a bone marrow biopsy. Anyway, my blood counts were way down. My immune system was very weak. My white blood cells were low. My red blood cells were low. ANC was low. Everything was low. And so that's why they were happy they put me in the hospital, because I was losing. COVID was winning because my immune system was destroyed. So
Thank goodness you're okay now.
yes, thank heavens for sure. Um, all those drugs, I feel a lot better than I have felt in weeks, I'll tell you. So they let me out last Thursday, wanted me to stay home till Sunday just to rest and quarantine just to make sure. They said that we don't think you're contagious anymore. You had it months ago, but just to be sure, infectious disease said to do that. So that's why I was emailing you guys last week and just trying to let you guys know what to do. And now we are ready for Module 4. Yeah, last week was our test. Let's put that up on our screen here. So here it was. Last week was the Module 3 test. So we had the practice test and test parts 1 and 2. I haven't taken mine since I was in the hospital. I had the practice test, but you saw I had a video. There's a video of me taking the practice test right here in Buzz. Let's go ahead and take a look at that, just for those of you who may have missed it. Right there, Mr. Brock takes the Module 3 practice test. So you can go there and watch me take the practice test. So if you took the practice test and got confused on some problems and couldn't figure out what was wrong, you could go look and see what I did on that problem. And my problem may not be exactly the same problem, but it would be a similar problem. And I explain how I got my answer on every single problem. So I already had that for you last week. So that was good since I wasn't able to be here in class and have the Module 3 practice test. But from that, we also had the test. So the practice test and the test last week. So that's what was due. This week, I think I'm going to change this. I know we're running right up to the end. We're scheduled. We want to finish Module 4 before Christmas because we don't want to try to remember everything. We don't want to try to remember everything through the break and then come back and take a test, right? We don't want to do that. We want to take the test before we leave for Christmas. So with that, we've got exponential functions and logarithmic functions and properties of logarithmic functions. That's a lot. I'll tell you, that's a lot. So I'm thinking of pushing one of these off, taking the properties of logarithms and pushing the next week, and then seeing one of these weeks, we're probably going to end up with 3 lessons or a lesson in the test. I'll just have to see. But I think 3 lessons this week is going to be too much because there's a lot in the lessons. So I'm going to change that. You'll see that change in Buzz here today. I'll go back and change the due date on this last one and push it back a week, and then we'll make adjustments going forward. But today we're going to talk about exponential functions and logarithmic functions. And yes, they're related to each other. They are actually related to each other. So we're talking about exponential functions. And let's talk about basically how an exponential function is 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 created. Um, an exponential function is one where the exponent is the variable. The x is the variable. It's up in the exponent. This is an exponential function. I should have seen some of this in Algebra 2, so hopefully this isn't a totally new idea to you. But that's an exponent. If we had x to the third, that is not an exponential function. Now that's a cubic function. I'll make that bigger. This is cubic function. That's cubic. It's not exponential. To be exponential, the variable has to be in the exponent. Right? So if we were looking at creating an exponential function, let's have an xy table here. How would we know this is an exponential function? Well, let's give it some x's and y's. 1, 2, 3, 4. And we're going to go 2, 4, 8, 16. Try to make those bigger. Okay. 2, 4, 8, 16. Right. So this is going to go up by 1 every time. Right. We see that 1, 1, 1. The x is going up by 1s. And what happens with the y's? This goes up by plus 2. This goes up plus 4. This goes up plus 8. Okay, so it's definitely not linear, right? If it's linear, goes up by 2, goes up by 2, goes up by 2, goes up by 2, or goes up by 8, 8, 8, 8. It's all the same if it's linear. This is not linear, right? So when we look and see how much they go up, it's changing every time. But if we look one more step here, what's happening here to here? How about it's times 2? Times 2. If we look at this, each one's times 2. 2 times 2, 4 times 2, 8 times 2. So we know the next one would be 32. We can see it because we know the pattern now. It's times 2. So when we see it's times 2, that means it's exponentially getting larger. Exponentially getting larger. So that means this is the function f of x equal 2 to the x, because it's going up times 2. 2. When x is 1, 2 to the first power is 2. That's what we got. When x is 2, 2 squared, that's 4. That's what we got. How about 2 to the third power? Well, that's 2 times 2 times 2, because that's how exponents work. 2 times 2 times 2, that's 8. When x is 4, substitute 4 in for x. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can verify that this is this exponential function right here, 2 to the x power, because every time it's getting higher by 2. If this was times 4, then this would just be 4 to the x, right? If it was getting 4 times 4 times 4 times 4, that would be our base number that we would use. Okay. All right. So that's a basic look at how we created an exponential function, how we can check it, using our table there. So let's talk about solving them now. So now that we understand what an exponential function is, let's talk about solving them. The most simple with solving, say, okay, 3 to the x equals 3 to the 5th. Well, that's pretty simple. The only way that would ever be true, that these are equal to each other, is if x was also a 5, right? Because 3 to the 5th equals 3 to the 5th. That's very, very simple. But what if we said 3 to the x equals 243? Oh, well, now that's a little harder. we need to know, in order for this to work, we can say x equals 5. See, we just set these equal to each other. Since these are the same base, if you have the same base, 3 and 3, you can just set these equal to each other. Well, these aren't the same base. This is base 3. This is base 243. But can this be converted to base 3? Let's see. 3 times 3 is 9. If we take another 3, that's 3 to the third. What's 9 times 3? Well, now we're up to 27. That's still not there. Let's take times another 3. So 3 to the fourth power. 3 times 27. 3 times 20 is 60. 3 times 27 is 21. 60 plus 21. That's 81. We're not there. So take it times another 3. 81 times 3. Well, 80 times 3 is 240 plus another 3. So this is 243. So this is the same thing as 3 to the fifth. If we rewrite it as 3 to the x equals 3 to the fifth, now we have the same base. We can just say x equals 5. But that's just, you got to figure out what this is. Put them in the same base. You got to have them in the same base. So let's take it up and make it just a little bit trickier here. Oh, wait. I think I had one. They're doing real tricky ones there. I don't want to get that tricky yet. Okay, let me make one up here. Let's go. We go to a new sheet of paper. Let's turn this on. What if we wanted to know 3 to the x minus 1 is equal to 9 squared? Okay, we're like, oh, okay. We got to figure out what x is. There's some power of 3 that we could take x minus 1 and it'll equal 9 squared. Well, like I said, if we can have the same base, so 9, we can convert to base 3. So this side just says 3 to the power of x minus 1. 9 is the same thing as 3 squared. Right? 3 squared. 3 squared squared. What's 3 squared times 3 squared? Well, 3 squared is 3 times 3. 3 squared is 3 times 3. When I multiply those together, that's 3 to the fourth. That gives me 4 of them. So 3 to the x minus 1 equals 3 to the fourth. My 3's are getting sloppy here. I should use a different number. Now we have the exact same base. They're both base 3. So when they both have a 3 as their base, now we can just set these equal to each other. Well, when is x minus 1 equal to 4? So x minus 1 equals 4. Add 1 to each side. So the solution is x equals 5. So 3 to the x minus 1, 5 minus 1, 3 to the fourth power is equal to 9 squared. Well, 3 to the fourth power, 3 times 3 is 9 times 9, 81. 9 times 9 is 81. 81 equals 81. So when x equals 5, this is a true statement. Okay, little tricky, but let's talk about, since we're at a good place to look at this, the properties of exponents, exponential properties. So if I was taking notes that I wanted to use on the test or the semester final, excuse me, this would definitely be in my notes. Properties. Let's talk about the product property. The product, as we know, is a math term. You get a product when you multiply things together. All right, so if I am multiplying, let's just say in general, x squared times x to the third. Okay, this is just the product of exponents. Properties of exponents. Let's do this. Right, now notice this is not an exponential equation because we don't have the x as the variable, but we just need to remember these properties of exponents. X squared times x to the third means we can add those together. So when we have the product, when we're multiplying product, we can add the exponents together. Add the exponents together, and that will give us the answer. Because if we look at it, this is x times x times x times x times x. Well, 5x's multiplied together is x to the fifth. So that is the product property of exponents, is that if you have the same base and you're multiplying them together, you can just add the exponents. Now, how about the quotient property? You get a quotient when you divide things, right? So if you're going to divide two different things, x to the seventh divided by x squared, x to the 7 minus 2, you can subtract the x to the fifth again. Well, see, how does that work? Well, you got x times x times x times x times x times x times x. That's x to the seventh, right? 7x's multiplied by each other, being divided by x squared, which is just x times x. Well, if you look, x over x is just 1, right? So this cancels out this. X times x is just 1. That cancels out that. So those are just 1. These are 1. So what's left is x times x times x times x times x over 1. That's x to the fifth, right? So the quotient property allows us to subtract when you have the same base. Right? Those both have to be x's. They both have to be 4s. They both have to be 10s, whatever they are. They have to be the same base. Powers of a power. This could come in handy. Powers of a power. All right. So if we have x to the third being raised to the fourth, that means we can take x to the 3 times 4, or x to the 12th. Powers of a power. When you take a power and raise it to a power, you can multiply those together, and it's x to the 12th. We saw a little bit up there, 3 squared times 3 squared, which is 3 squared squared. You can just multiply those together, 2 times 2, and end up with 3 to the fourth. Because that's what it is. 3 squared squared means you're taking 3 squared times itself, which means you're taking 3 times 3 times 3 times 3. It gives 3 to the fourth. So powers of a power, when you're taking a power to a power. As instead of let's call that 2. Power to a power. You get to multiply those together. And then the last one I want to review is negative exponents. All right, negative exponents. Just in case these come into play as we deal with our exponential equations, all of these properties of exponents do apply. All right, so a negative if we have a negative exponent, if you have x to the negative 2, that is the same thing as 1 over x squared. If it's on the bottom, let's say this is 3 over x to the negative 4th. We take this to the top. That's the same thing as 3x to the 4th. Because x to the negative 4th is the same thing as x to the 4th. X to the negative 2 is the same thing as 1 over x squared. So, properties of exponents that we just need to review before we move on here. All right, let's talk about solving. Oh, no, there's a video on. I would solve this one, but there's a video. There's a video that shows you how to do 1 over 256 equals, what is it on the screen? 16 over x minus 9. See, this is the exponential equation because x is in the exponent. So there is a video in our lesson, page 4, that will show you. So I'm not going to go through that because you can go through that yourself and see the video. There's also a video. Well, there's some steps you through a square root would also. So I will leave that for you to do. We're going to take up enough time in class today. So that's something you need to review in our lesson today on that. So let's talk about applications. Applications. Let's say you had a genie pop out of a bottle and give you a choice. You can have for 1 month. For 1 month, let me see, am I talking about a 30-day month or a 31-day? A 30-day month, November. You can have $100 a day. Or you can have 1 cent the first day, and I'll give you 2 cents on November 2nd. I'll give you 4 cents on the 3rd. I'll give you 8 cents. Which one would you like? Put that in the chat. Let me see what you like. You want to give it for the month of November. Do you want $100 a day, or you get a penny on November 1st, you get 2 pennies on November 2nd, you get 4 pennies on November 3rd, and every day I'll double the amount of money you're giving. That's what the genie is going to do for you. Put in the chat and see which way you want. Now, here's the good news. You can't lose because either way, you're going to have money, right? Either way, it's free money. But which would you rather have? Go ahead and give me that penny. I'll take a couple pennies, take 4 pennies. Nicholas says, I'll take the penny also. Double, penny, 1 cent. All right. Everyone seems to be thinking, if I just take a penny and just double it every day for the month of November, I'll be all right. See how many pennies you have by Thanksgiving and get to the end of the month. Maybe you can do some good Black Friday for shopping. Of course, by Black Friday, let's see, what is Black Friday this year? This is the 14th, 15th, 16th, 17th, 18th, 25th. So you'd have $2,500 by Black Friday for $100 a day. But I wonder how it would do with a penny a day. All right, well, let's look at this. It has this example in our lesson, so I'll put it over here to show you. So, $100 a day. 30 days, you're going to end up with $3,000 by the end of November. Right? $3,000. If I gave you a penny and then doubled it every day, okay, looky there, by the 25th, which is Black Friday, you'd have $167,000 that you're given. Now, that's just for that day, right? Because I get 1 penny, 2 penny, 4 penny. And then you get $5 million on the 30th. Exponential. If you can get exponentially more money, in the long run, you're going to win. Say in the long run, because look, up until at day 14, you're still only getting $81. You're still better off at $100 a day by day 14. But it doesn't take long after that to catch up for all that missing. When you're just getting a penny and somebody else getting $100, you're catching up real fast right here. 10, 20, 41, 83, $167,000. So definitely you want to go exponentially more. All right, good job. Couldn't fool anybody on that. Let's see. Let's talk about interest, because that's kind of what this is looking at. Is looking towards money and interest. All right, fabulous. There's a formula that, again, I would certainly have in my notes. The amount of money you have starts with your principal, not Miss Scott, but the principal amount that you have to invest at the beginning. 1 plus R over N T. Okay, what's all these letters you have in here? P is the principal. Principal. See, we'll spell it different. Which the PAL would be Miss Scott there. Okay, so that's the amount you start with. That's the amount that you're putting in the bank. 1 plus R. R is your rate. And that would be a decimal. If you're making 5%, you have to put that as a decimal in this formula. 0.05. 5 out of 100. 100% is 1. This is just 0.05 out of 1. 5%. So it has to be a decimal. N. The N is number of times compounded per year. Means how often are they giving you this interest? Do they just give you interest at the end of the year? Right? Or are they giving you interest throughout the year? And then the last thing, the other variable, is T. Right? T. That's the years. Time in years. How many years are you leaving this money in there? How many times, how many years are you taking this money and leaving it in there? So let's look at a problem and see how much money we have. Let's say that we have, all right, we got $1,000. Grandma was very generous this Christmas and gave us $1,000. It's like, Grandma, what'd you do? Did you sell your false teeth or something? I don't know, but Grandma wanted to give us $1,000. So we've got $1,000. So our P is 1,000. And Uncle Joe works down at the bank, and he says, hey, I've got this interest rate that I'll pay you 4% interest, 0.04, which is 4%. And he says, I'll pay you interest every month. So every month, that means the number of times compounded per year. That means 12 times a year you're getting interest. So after the first month, you're getting 1 month's worth of your 4%. And that'll be added to your $1,000. In month 2, you get 1 month of your 4% of the $1,000 plus the interest you got added the first month. So now you're making interest on top of your interest. That's how your money makes money. You make interest on top of your interest. So the more times, the bigger the N, the more money you make, because that's the more times they're going to give you interest. And each time you'll get interest on top of your interest. And they say, what happens if we leave it there? We're not going to touch it for 10 years. All right. So how much money will our $1,000 be worth in 10 years? So we just need to plug that in. So the amount of money we have will be 1,000 plus 1 plus 0.04 divided by 12 NT. That means they're multiplied. N is 12, T is 10. 12 times 10 is 120. So let's get out our calculator and do some calculating. That'll be wonderful. First, let's calculate the 0.04 divided by 12. 0.04 divided by 12. That's 0.003333. So this, if we want to simplify it, 1,000 times 1 plus 0.00. I'll put 4 threes there. So that'll get us a ways down the road. Okay, because we added that. If we say plus 1, right, that's the 1.033333. It just keeps going. Okay, so now order of operations. We've got multiplication and we've got exponents. Right? There's nothing to do in the parentheses. We already did what's in the parentheses. PEMDAS, right? PEMDAS. We've already done what's in the parentheses. P we've taken care of. Next is exponents. So we got to take that times 120. So I'll use the number in my calculator there, which is not rounded. I've just left it as what it was. Let's take that to the power of, see, it's got this X to the power of Y button. So I take that and I'm taking it, see, it puts a little caret up there, to the power of 120. So there it is, to the power of 120. That means 10 years later, we got interest every month, 120 months. It's 1.49. And then we take that, because that's what this number is, take it times 1,000, times $1,000. And there's the amount of money we end up with. A equals $1,490.83. So you made almost $500 by doing nothing, letting your money make money in an account, making 4% interest monthly, and you left it there for 10 years. If you could get this weekly, it'd be worth more money. If every week they would give you interest, let's look at that real quick. The only thing that would change would this would be 52 times 10 or 520, right? And this R would be divided by N. So we'd have to change that number. Let me write it below. A equals 1,000 times 1 plus 0.04, because we get 1 week's worth of their 4%. Let's see what kind of difference it makes if we got it once a week. So 0.04 divided by 52. Let's do that first. 0.04 divided by 52 minus 4. So this means there's zeros in front of it. So we're getting into a small number. 1,000. If we add 1 to that, plus 1, it'll give it to us. 1.000. It was given us scientific notation before. Okay, to the 520th power. All right, so I'm going to take this number, that's the 1.076, all that, to the power of 520. So x to the y, 520. Oh, it's not going to make a big difference here. Times 1,000. Changing it from monthly to weekly, we end up with 1,491.60. Look at that. We only made about 77 more cents by getting it once a week instead of once a month. All right. So what's going to make the difference is getting a higher interest rate, longer term. But monthly and weekly doesn't make a huge difference, because you're just getting it a little bit more often, but you're still just getting 4% a year. It doesn't change the amount you get per year on that. But understand how to use interest, calculate interest. You have some questions on that in this week's assignment on calculating interest. So make sure you have this formula and know how to use it. All right, so I'm recording this class if you need to go back and look at how to use it. Okay, so that is the exponential functions lesson. We want to go forward and look also, while we're here, at the log functions lesson, logarithms. Because logarithms are related to exponents in the fact that the same way that division is related to multiplication, they undo each other. They undo each other. So let's look at a sample exponential, a log function here. Let's see. Okay, so the way you can convert y equals b to the x, that's an exponential function, right? A logarithmic function would be x equals log to the base of b of y. You're like, okay, what do you mean? Well, let's put some numbers in here. Let's say that 100 equals 10 squared, right? 10 squared is 100. So if we wanted to know what log base b, log 10 of y, so for base 10, what is the log of 100? In other words, what exponentially do you need to multiply? How many times you got to multiply 10 times itself to get 100? And that's 2. See, these are opposites of each other. This will undo the x, the exponent, the variable. We can go backwards and solve with logarithms. X2. So if we had, let's see, here's one of the examples from our lesson. Log 8, 512. And you're like, log 8? What does log 8 mean? That means everything's to the 8th power. Log 8 is 0 is 1. 8 to the first is 8. 8 squared, 64. So it's using base 8 for your exponent. This uses base 10. That's what, if you see the log button on your calculator, it just says log base 10, because that's what our number system is based on. We are a number 10 base system. So 10 is standard. This is the exact same thing. See, if I don't write the base, I didn't put the base in there, then it is assumed I'm talking about base 10. So these are equivalent statements. If I want a different base than base 10, I have to put the base in there. So what this is asking is, if I look at this, B 8, this is Y, see, Y, 512 equals 8, and we don't know what it equals. 8 to what power equals 412? What is log 8 of 512? That's what it's asking. Log base 8 of 512. How many powers of 8? What exponent does 8 have to be at to equal 512? How many times 8? Well, there's 8 squared. We take 64 times another 8, right? You get 32, carry the 3, 48 plus 3, 512. So this equals 3. X equals 3. That's what equals the X. 8 to the third power equals 512. So logs and exponents are kind of like multiplication, division. They're opposite of each other. So the base is this. We call that the base. This is base 8. That's base 10, base B. Okay, that's why we use B as the variable for that. It's the base number for that. Let's see, they give us a good example problem. They have a video. Again, there's a video that you can watch. Log 5 of 1 over 625 equals what? And I'm not going to do that one because there's a video on page 4 of lesson 4.02. 4.02, page 4. Need to watch that video because it will walk you through that. So I'm not going to walk you through that. And so basically the logarithm is how are exponential functions related to log functions? Well, they're opposites. They like multiplication, division. So a logarithmic function is the inverse, is what we call it, the inverse. Multiplication and division are inverses of each other. These are inverses, exponential and logarithmics. So you could write it in log form where B is the base, or in exponents where B is the base, right? B is the base, either one. So you can also have logarithms that are base E, right, of a number. 2.718. E is a number in mathematics. Remember, E is equivalent to 2.718218 ... It continues. It's kind of like pi. It keeps going. Right. Good. But if we use log base E, they do different terminology. So you don't have to write the E every time. They would say ln. What's the ln of 10? That means log base E 10. Log base E of 10. And your calculator, probably even the simple calculator, has that on there somewhere. Let's see. We have logarithms on here. Oh, there it is. Log and log 10. Log ln, log E. So like 10, if I want to know what log E of 10 is, it's 2.3. If I raise E to the power of 2.302585092999, it'll equal to 10. This is base 10. So if I want to know log of 10, it's going to be 1, right? Or 0, 1. 1. Log 10 is 1. So power 10 to what power equals 10? Well, 10 to the first power. So log base 10, log base E. So those are both in there. So, all right. Like I said, there's a lot in this week's. We've gone about 45 minutes in all of this. I'm going to stop presenting that. Like I say, I'm going to go ahead and cancel the third lesson, push it off to next week, where we talk about the properties of logarithms. Right now, I'll just go through these 2 lessons. Look at those videos because it gives you some good examples, more explanation with those videos. You have 2 assignments to do this week, multiple choice assignments over exponents, and then it's inverse logarithms. So it's a good pairing to put together. And then next week, we'll go a little bit deeper into that. But anyway, I'm happy to be back. Happy to be with you guys again this week. We'll have class on Wednesday for anyone below 70% or anyone with questions. And I'll be here for that. So I'll let you guys go. Have a great week. Happy Thanksgiving.